The tap operator lets you spy on a source observable, performing side effects while not impacting the underlying stream. Tap is extremely useful when debugging or inspecting observable behavior. I wanted to go ahead and cover tap now in the initial operator section, as it will come in handy while looking at more complex operator behavior moving forward. To check out how tap can be used, let's start with the basic example from the map lesson, where we are using map to transform a stream of numbers into a stream of numbers multiplied by 10. The most common use case for tap is putting checkpoints into your streams while debugging. For instance, suppose we want to check out how the values looked flowing through this number stream, before and after map. To do this, we could utilize the tap operator. Let's go ahead and add tap to our args.js/operators import. Next, let's add tap to the pipe method before the map operator. Tap accepts the same arguments as the observable.subscribe method. For this example, we will just provide a next function which will be invoked on each emission from the source observable. Let's just log the word before and the emitted value. Next, let's actually copy and paste this tap after the map operator, and we'll just update the log to say after instead of before, so we can check out how the stream was transformed before and after map. When we run this, we can see the original value is logged before, with the value multiplied by 10 after the map operator. Although this example seems trivial, you will often find yourself sprinkling logging into your streams just like this when you run into issues you need to track down through more complex operator chains. As you probably also noticed in this example, tap completely ignores any returned value from the function you provide. To confirm this, let's just hardcode a return of 100 into the first tap operator function. Now, when we run the solution, you can see nothing changes. The return value from tap is simply ignored. Let's go ahead and undo this and just return to the console.logs. Tap also accepts next, complete, and error callbacks should you want to trigger a side effect on these notifications. Let's swap out the single next function in our tap operator here with an object. We can maintain the same function for next, but let's add a property for complete, and we'll just give it a function that logs done to the console. Now, when we run the example, you can see the function we provided for complete in tap is called and logs done after the observable emits all 5 values and then completes. If you wanted to, you could also provide an error callback to this observer the same way we provided next and complete properties. To check out a case where tap can come in handy, let's take a look back at the countdown lab. If you recall, I mentioned in the lab that although the filter operator was preventing our UI from updating after 0, we still had an issue with our interval running behind the scenes, continuing to emit values. Although I said it, I didn't prove it at the time. To prove this, we could use a tap operator to spy on the stream and log values before the filter operator. Let's go ahead and add tap to the args.js/operators import above. Next, let's add the tap operator with a console.log to the pipe method before the filter operator. This will let us see values being emitted before they are filtered out by our filter operator below. When we run this now, we can see by using the tap operator as a logger that values continue to be emitted even after our display stops at 0. In an upcoming lesson, we will see how to prevent this from happening by completing the observable when a certain condition is met. The last thing I want to bring up regarding tap is really just a word of warning. In the example from the map lesson, I'm creating a stream of event codes from a stream of keyup events. Instead of just logging the code to the console, I'm instead subscribing and updating the UI to show the code for the last key hit. Now, once you get used to using tap, it may be tempting to start moving side effects out of the subscribe method and into tap functions, like so. While the example still runs the same, this could create problems down the road if you are not careful. For instance, say somewhere down the line we want to use the keyup stream to create just a stream of enter events. Let's go ahead and import filter, and create an enter stream by using the keycode stream and the filter operator, supplying a function to only accept values where the code equals enter. When we subscribe and run this, we would probably be expecting only enter events to be logged. But instead we see events for everything. This is because since we moved the DOM update to the tap operator, we are unknowingly dragging side effects around when we are just trying to use the keycode stream to create another stream. It is for this reason I suggest, when possible, you keep side effects such as these in the subscribe method, and you try to use tap for behavior such as logging whenever possible. It will certainly help you avoid headaches down the line. To recap, tap is a heavily used operator for inspecting streams, particularly for debugging purposes. Avoid jamming other side effects into tap wherever possible, as it can cause headaches as your application grows.